here, and I'm making another video for you in the playlist, Learn R the Easy Way. And so basically what we're going to do is we're going to talk about some descriptive statistics in R. And so basically R is a statistical programming language written by statisticians for statisticians. And so R has some great functions in it that are inbuilt into the programming language that enable you to get statistical formulas automatically and get the statistical values. So that way, whereas in Python is a general purpose programming language, and although Python has like math, which is an inbuilt mathematical library, and I think statistics or stats, which is an inbuilt statistical library, some of these statistical functions, if you want them, you may have to use another library to get them, such as SciPy or stats models. But R is unique where it has many of the statistical programs and statistical functions inbuilt into the programming language. And so what we're going to do in this video is we're going to talk about some of the code that's inbuilt into R. So the first thing that we're going to do is we're going to create a vector, and we covered data structures in R in a previous video. But so we're going to create a vector. So vector becomes C brackets, and it's going to be 1 to 20, but it's not in order. So because it's not in order, that enables us to calculate the median. And the number 20 appears twice. So that's going to enable us to use some of the mode function. So first thing that we're going to do is we're going to calculate the mean. So cat is like a print function, but it allows you to print text with your print function. So cat mean colon mean v n. So we're going to get the mean of v, which is your vector. So the mean of v is going to be 10.95. And then what we're going to do is we're going to cat brackets median colon median v. And the slash line, I think that's an oblique n, means next line. So now what we're going to calculate is the median of n. Now, median of v. Now the difference between the mean and the median is with the mean you take the sum of all the elements of the vector, and then you divide that by the number of elements of the vector, and that gives you 10.95. The median is different because the median is you take all of the elements of the vector and you sort them. And then when you sort them, you take the middle element, and your middle element is median. And that's how it works if you have an odd number of elements in a vector. If you have an even number of elements in the vector, then what you do is you take the two middle elements, you add those, you take the two middle elements, you you add them together, and you divide them by 2, and that is your median. So we're going to look at the median, and your median is 11. So now we're going to select the mode. Now the mode is the number of times an element appears in a vector. And so what I did was I put 20 in there twice. And so because I put 20 in there twice, that means all of the elements in the vector appear once except for 20, which appears twice. So the mode is going to be 20. So we come over here and we say our mode is 20. So now we're going to take the minimum value. So cat brackets min value, comma, min v, next line. So your minimum value is going to be 1 because I typed it in and another minimum value. And so now what we want is the maximum value. So again, cat brackets max value, comma, max v, comma, next line. So the maximum value is going to be 20. And then we're going to check the range. So the range is going to be 1 to 20. That's the range of numbers in this vector. And then we're going to check the sum. And that's when you check the sum, what you're doing is you are adding all of the numbers in the vector together. And in this instance, we have a sum of 230. Now, what we want to check is the length. So the length is the number of elements in the vector, and there are 21 elements in the vector. Now what we want is the quantile. So the quantile automatically calculates it as 0, Q1, Q2, Q3, and Q4. So 1 is your 0, and Q1 is 6, Q2 is 11, Q3 is 16, and Q4 is 20. And now what we want to check is the IQR. That's your interquartile range. So your interquartile range is going to be about a Q2, I believe. And so, let me just see if we can find this. Your IQR is going to be 10. So that's going to be your Q2. We're going to check the variance, and the variance is a statistical value where it checks the variance, and then it's also a mathematical formula to calculate the variance, but I'm not going to go into the mathematical formula in this particular video, but your variance is 37.54. And then you want to check your standard deviation, where your standard deviation is the square root of your variance. And it is another statistical formula, and your standard deviation is 6.12. See if I can. So we've got our median absolute deviation. And so your median absolute deviation is sort of like the standard deviation, but it uses the numbers in the vector in a different way. So your median absolute deviation is 7.14. And then you've got your difference range of the vector. And so that's going to be range of width of range is going to be 19. And the last one, we're going to check the summary. So the summary gives you a minimum, a first quartile, a median, a mean, a third quartile, and a max. So those are the statistical functions that you can use, inbuilt functions that you can use on a vector. So now what we're going to do is we're going to talk about 2 keys, 5 number summary, which is another statistical function that you can use on a vector. It gives you the minimum, the lower hinge, the median, the upper hinge, and the max. So it gives you 1, 6, 11, 16, and 20. And so now we're going to cover some functions that can be used in a data frame. So we're going to create a data frame in R with 4 columns, and each column is going to have 15 numbers. So this is the data frame that we have created in R. And you can see that it has 4 columns. First column is 1 to 15. Second column is 16 to 30. third column is 31 to 45, and fourth column is 46 to 60. And so we have created a data frame in R. So now what we're going to do is we're going to have the summary of the data frame. So you can use the summary function on either a vector or a data frame. So in this one we have summary df. So you have the summary for column 1, column 2, column 3, and column 4. And it gives you the minimum, the first quartile, the median, the mean, the third quartile, and the maximum for each column. So then what we're going to do is we're going to apply the mean across all columns of the data frame. So let's go S apply brackets df comma mean. So column 1 is 8, column 2 is 23, column 3 is 38, column 4 is 53. And then if you want a different function, you can say median or sum or min or max. You can use any function within R that you would like. And in this particular one, I just said mean. So now what we're going to do we're going to aggregate if the data frame has no grouping variable. And in this particular instance, the data frame does not have a grouping variable. So you use the formula aggregate brackets df comma by list brackets rep brackets 1 comma in row brackets df brackets comma fun means function equals mean brackets square brackets -1 square brackets. And so what we're going to do is we're going to aggregate the data frame when it does not have a grouping variable. And so you've got column 1, column 2, column 3, column 4. So your mean is 8 for 1. The mean is 23 for 2. The mean is 38 for 3. And the mean is 53 for 4. And you can see that those values are exactly the same as we had in the previous cell, which was S applied DF mean. So now we're going to do an aggregate with a formula interface. So you can also put a formula, sorry about that, you can put a formula into this function. So aggregate brackets dot, and that's a squiggly character, I think is a tilde 1, comma, data equals df, comma, fun, that's function equals mean, brackets, square brackets, -1, square brackets. So you've got the data frame 1 times 3, it says column 2, column 3, column 4, and again you have column 2 is 23, column 3 is 38, and column 4 is 53. So that gives you your mean, and it doesn't give you a column 1. So it might be better to use a different syntax for aggregate that would give you all 4 columns, such as the S apply, which isn't an aggregate, but the aggregate brackets df, comma, by equals list brackets rep brackets 1, comma, in row brackets df brackets, comma, fun equals mean brackets square brackets -1. So I just put that in there so to show that to you. So like when you use the function, it doesn't include column 1. So that's not very good, but I'll go ahead and leave that in there just so you can see how it works. So now we're going to have 5 num for compact output. Again, we're going to do S apply brackets df is your data frame, comma, 5num is the inbuilt function. So again, for column 1 to 4, you get the 5 nums, which is the bottom, the lower hinge, the mean, the median, the upper hinge, and the top. You can have 5num for a list, which is L apply, brackets df, comma 5num. So you can put a function within a function in R. So column 1, again, it gives you your 2 keys, 5 numbers, which was the lowest number, the lower hinge, the mean, the median, the upper hinge, and the top for column 1, 2, 3, and 4. So now we have 5num for a summary of each column. So if you want to do the 5num for a data frame, say for call in names, brackets df, and then parentheses or curly brackets, cat brackets, 5 number summary for column, and square comma oblique in. You have print 5num brackets df, square brackets column, square brackets brackets. And so what it does is it gives you your 5 number summary for all 4 columns. And that's, again, you could get the 5 number summary if you used L apply. So that's 2 ways that you can do it if you want to. So now we have the table function. And so what we're going to do is we're going to create a table, becomes C brackets, A, comma, B, comma, A, comma, C, comma, B, comma, A. And then table X becomes table brackets X. So we print table X, so that tells you you have 3 elements that are A, 2 elements that are B, and 1 element that is C. And then now we have proportions of a table. So you've got prop.table brackets table X, which is a little bit different from table X. And that gives you the proportions. So you have 50% on A, 33% on B, and 16.7% on C. Or 17% really on C. And so now we're going to aggregate the data frame by group so you can see how you create a data frame that has a group in it. So group equals, df1 becomes data.frame brackets, group equals rep, that's repetition, bracket C, brackets A, comma B, comma each equals 5, and then score, you get the number of elements for each vector in score, and you get a number of elements for each vector in value. So you've got now df1, you can say you've got your data frame. So with group, you have each row, the first 5 rows is A, the second 5 rows is B, and the third 5 rows is C, and then you have the score for each row, and then you have the value. So we're going to get the mean of each numeric column by group. So aggregate brackets C by, comma, score, comma, value, and that's a squiggly, and it's your group, comma, data equals df1, fun, which is your function, equals mean. So you can say that the group is A and B, the score is 14 and 24, and the value is 5 and 10. So that's not very good because the data frame is 2 times 3. but you did have A and B. So you had 10 elements in each vector. So you do have A and B. So now we're going to sum of each numeric column by group. So aggregate, brackets, C bind, brackets, score, comma, value, and the tilde, group, comma, data equals df1, fun equals sum. So now you're going to calculate the sum of each of the elements in the vector for each group. So in A, the score is going to be 70 and the value is 25. And B, the score is going to be 120 and the value is going to be 50. So those are just some of the statistical functions that are built into R that you can use. And then so that's a great thing about R. So if you're planning to do a lot of statistical work, then you might want to use R as the programming language to carry out this statistical work. And these are just some of the inbuilt functions that you can use in this programming language. So I'm going to go ahead and conclude this video. The next video I make, I'm going to be covering some more R-type subjects, and the playlist Learn R the Easy Way, and I hope that you decide to watch it.